Hello, welcome to my channel. In today's lesson, we'll be proving this identity where they say we should prove that sine square x over 2 equals to cosec x minus cot x all over 2 cosec x, and this is also the second one. So we'll be starting with the first one. We're going to prove either the right hand side equals to the left hand side or the left hand side equals to the right hand side. Whichever way we start is still the same thing. So now, to resolve this problem, we said sine square x over 2 must be equal to cosec x minus cot x all over 2 cosec x. So now, to prove that this right hand side equals to this, we are going to relate this with our half angle formula, which we derived last class. So now we know that the half angle formula, we said from our half angle formulas, we derive that sine alpha is equal to plus or minus square root of 1 minus cos alpha all over 2. So now this is the formula we derived last class, 1 minus cos alpha over 2. But here, this is sine alpha over 2, half angle. Sine alpha over 2 equals to this value. But remember, what we're dealing with x, not alpha. So now I can change this sign. Instead of alpha, I can write it as x. The angle of inclination here is x, right? So but this one is squared, but the half angle here is not squared. So I'm going to square this and square this also, meaning take square both sides. We're going to square both sides. So now by squaring both sides, I will have sine square x over 2 is equal to, when I square this one, the power will cancel the square root here. So now I'll be left with 1 minus cos x over 2. So instead of writing sine square x over 2, I can substitute it by this value from the first identity. So now taking this here, I will now say this is the same thing as say 1 minus cos x over 2 is now equal to this function here, cosec x minus cot x all divided by 2 cosec x. So now this function must now be equal to this function. That is our target. We are going to prove that this is equal to this. So now, considering this, our target is to achieve this. And what is cosec x? By definition, we said this is an inverse identity, right? So now cosec x is 1 over sine x, right? So now our target is to achieve something like this. So now, if I multiply this function by 1, see 1 minus cos x all divided by 2. If I say this times 1, mathematically I didn't do anything because any number times 1 is the same thing as that number. But my target is to achieve something. So now we must accept idiosyncrasy here to enable us prove this problem. Now, instead of writing 1, it's still the same thing as saying 2 over 2. 2 over 2 is still the same thing as saying 1. I can multiply this by 2 over 2. 2 over 2 is still 1. Or I can multiply this by sine x over sine x. Sine x over sine x is also 1. And at the same time, I can multiply this function by 1 over sine x divided by 1 over sine x. It's also 1. 1 over sine x divided by 1 over sine x is also 1. So I didn't do anything mathematically to the equation, but I'm trying to achieve something. So now, let me multiply this by this function. I'll multiply the numerator by numerator, denominator by denominator. So now, on multiplication, I have 1 minus cos x times 1 over sine x. Divide this by 2 times 1 over sine x also. So if you multiply, you are going to have, multiply this by 1, you have 1 over sine x. Minus, multiply this by this, we have cos x over sine x. Then divide this. Multiply this by 2, you have 2, 1 over sine x. right? So remember, 1 over sine x by inverse identity is cosec x. So instead of writing 1 over sine x, I can write it as cosec x. So this implies that I have cosec x minus cos over sine is the inverse of 1 over tan. 1 over tan is sine over x. Sine x over or cos x is tan, sorry. Then cos x over sine x is 1 over tan, and 1 over tan is cot x. So we have cot x here divided by 2. 1 over sine x is cosec x. So now this right hand side, is it equal to the left hand side, which is cosec x minus cot x divided by 2 cosec x. So are they equal? If they are equal, then we have proved the identity. This is equal to this, meaning sine square x over 2 is still the same thing as cosec x minus cot x over 2 cosec x. Right? So now, since they are equal, then we'll be able to prove this identity also. So now, on the comment section, please draw, on the comment section, kindly write the value or prove that this function is equal to this function. You write it on the comment section and we'll check and see who got the values correctly. Thank you for your time. If you are visiting the channel for the first time, please do well to hit on the subscription button and give us a thumbs up. Thank you and stay blessed.